Hello. In this talk, we address the question, how do we evaluate self-adaptive software systems? This is joint work with Ilias and Patricia from the University in Amsterdam, Thomas from Berlin, and myself from Leuven and Linnaeus University. I will start with introducing our study, and then Ilias will elaborate on the results and the main findings. Now, our field is by now already 2 decades old. It all started with a number of seminal papers by O'Reilly and Jeff Keppert and David Garland. And from that, we developed a whole bunch of solutions to engineer self-adaptive systems. We have done runtime models, we have languages to specify and implement self-adaptive systems. We have looked into planning, analysis techniques using verification, you name it. In the last years, we also were pretty active in developing exemplars. We have by now 23 exemplars for a variety of domains. You see a few screenshots here from these existing exemplars. Now, these exemplars are interesting for our community as they allow us to better compare our findings. Our new results can be better compared with state of the art, and that allows us to build a body of knowledge in our field in a more systematic way. Yet if we look at literature and we want to understand how do we evaluate self-adaptive systems in our research, it's not all that clear. And there have been done a few studies that looked in particular aspects of evaluation, particular quality properties, but there is not so much clear view on how these evaluations are actually performed. So, and that's why we performed this systematic mapping study, which aims to bring structure in this field. Now, the focus of our study is threefold. On the one hand, we look at papers published in the last decade of SIMS. As I was saying, we also zoom into papers that look at architecture-based adaptation, meaning that they are in essence based on the reference model, the MAPE-K reference model. And most importantly, what you can see here, we look at experiments, which are the major way to evaluate solutions in our novel contributions in our field. Over 65% of the evaluation methods are experiments. Now, with experiment, we don't mean per se a controlled experiment, which is a systematic method that is precisely described in literature. We are here taking a little bit looser interpretation of experiment, and we look at those papers that do quantitative comparison of the results of a new approach using experiment configuration. So they compare their new approach with an existing approach using a quantitative method. Now, to get insight in these evaluations, we defined 5 research questions, and these research questions are based on a well-established experimental process that has been described in Klaus Williams' book on experimentation in software engineering. So we zoom into these questions first on the scope of experiments, then the design, how experiments are operated, how the data is analyzed, and finally, how the results are packaged. Now, for each of these research questions, we define then data items, and these data items allow us to collect the information we need to answer the research question. So for scope, we looked at what are the contributions of the papers and what are the objectives of the evaluation. For the design, we looked at things as the independent and dependent variables, among others. How experiments are operated, we looked, for instance, at what type of managed systems are used, how is uncertainty modeled in the system, etc. For the analysis, we looked at what type of analysis has been done, how is the evaluation problem answered, what are threats to validity that are discussed, for instance. And finally, for the packaging, we looked at, is in essence, the degree of reproducibility of the results. Here you see an overview of the study design in different stages. So as I said, we started in bullet 1 there with selecting all the papers from SEAMS in the last 10 years. Those were included, including criteria 1, as I noted there. That were in total 224 papers. Then we filtered out those papers that were not full research papers because we were only interested in full research papers, left 126 papers. And then we filtered out those papers that were not doing any technical contribution, but rather surveys or overviews or literature reviews, and that left us 119 papers. And these papers then were more in-depth studied, and we looked then at, are these papers reporting experiments, at least one experiment. And those that did that were included, the rest was excluded, so that left us 82 papers with in total 140 experiments. And then these papers went into an in-depth study where we extracted all the data items that I was showing you before. And then we start analyzing that data and structuring that data. And finally, we wrote the report, actually the paper that we present here today. So with this, I have introduced the study. I leave now the word to Ilias, who will discuss the results. Thank you.
Hello. Let me now guide you through the important results of our study. They are structured according to the 5 research questions that you can see at the bottom of the slide, namely scoping, planning, operation, analysis and interpretation, and presentation and packaging. Looking at scoping, one of the first questions we wanted to answer was what is the target of evaluation? To do this, we extracted the contributions from every paper and classified them according to the phases of the MAPE-K loop as planning methods, analysis methods, monitoring, and execution methods. When an approach was focusing on more than one phases, it was classified under feedback loop approach. We also identified learning method approaches. That was a category that emerged from our analysis. As we can see from this graph, clearly most of the evaluations evaluate new feedback loop approaches. We also saw that, especially in the last years, there is an increase in the evaluation of learning methods. Secondly, we wanted to understand what is the objective of evaluation, or why the experimental evaluation was performed. As you can imagine, an experiment can be performed to measure the effectiveness of an approach, whether the approach works, or the learning ability, what is the accuracy or sensitivity, time efficiency, whether it's, for instance, tractable at runtime to use a certain, for example, planner, whether it scales, whether it's robust, etc. From this graph, we can clearly see that the majority of the approaches at SIMS evaluate the effectiveness of a new method, whether it works or whether it works better than another approach. Going into planning, we were interested to understand what we measure in SIMS experiments. By that, we mean what are the dependent variables in the experiments reported at SIMS. We extracted the dependent variables and classified them according to 2 categories. Firstly, according to whether they refer to the managing system, the managed system, or both, or the user. And secondly, according to qualities that are referred to the ISO IEC 25010 standard, and namely time behavior, functional appropriateness, resource utilization, functional correctness, and reliability. What we can see here is that we mostly measure time behavior in SIMS experiments, and this comes in terms of measuring latency, response time, processing time, planning time, etc. Next, we were interested to understand what do we change in experiments, or what are the independent variables in the SIMS experiments. We extracted those and classified them again into 2 categories. First, into whether they refer to the managing system, managed system, environment, cross-cutting, which means that it would refer to more than one of the previous categories, or the system goals. We also categorize them into constants, blocking factors, and factors. Constants were the variables that whose values did not change in an experiment. Factors were the variables whose values changed in an experiment, and blocking factors were used for creating analysis blocks. What we can see here is that we mostly evaluate new approaches and methods of the managing system. In particular, the majority of the factors, so the variables that we change, have to do with either a method or a variable of the managing system. And we can also see that the variable, the environment parameters are mostly kept constant. Next, we wanted to identify any patterns between the evaluation objective, the independent and the dependent variables. And indeed, we managed to identify 4 such patterns. I'm showing 2 here, and I will just briefly describe the first one. That has to do with experiments that were measuring the effectiveness by comparing 2 methods of the managing system, method 1 and method 2, and measuring the resource utilization of the managed system and the time behavior of the managed system. This was the most popular pattern, and it's a classic comparison of, let's say, a newly proposed method against a baseline. Next, in the operation phase, one of the questions we posed is how uncertainty is represented in SIMS experiments. So we extracted the different representations of uncertainty and again classified them according to 2 dimensions, according to the modeling of uncertainty that could be classified into predefined model, random model, unclear or probabilistic model, and according to what the uncertainty is capturing, whether it's human, context, system, or goals. What we can say here is that we mostly represent uncertainty related to the context, which makes sense because the execution context is what typically needs to be changed in an experiment. And we also found out that in the majority of the cases we use predefined ways of specifying different change scenarios. On the analysis interpretation, one result is that relates to how the experiment data is analyzed. So for this, we identified 3 categories: exposition, descriptive statistics, and statistical tests. Exposition means that some kind of narrative or text is used to describe the result of an experiment. Descriptive statistics is when, apart from some narrative, there are also some statistics or some plotting reported. And statistical tests are on top of extra statistics. Also, statistical tests have been executed. We know that even though there are some statistical tests in some experiments, there are not so many, and also the motivation behind the choice of statistical test is not always motivated. Finally, on presentation and packaging, we were asking whether the experiments can be reproduced. And for this, we classified primary studies into the ones having no code provided and no replication package, others that provided the code but did not provide a full replication package, and a small category of papers that provided both a code and replication package, meaning the input data and instructions how to run and replicate the results. So this is a small number, and we believe that more papers can offer more complete replication packages in the future. Let me now conclude via providing the main insights and suggestions of our study. Regarding scoping, we found that the target of an experiment in adaptive systems is a new method of the managing system. Regarding planning, usually a method of the managing system or a part of it, such as a learner or a planner, is a classic factor of a SIMS experiment. Regarding operation, we found different ways of representing uncertainties. However, we believe that we can improve here by including more probabilistic modeling of uncertainties. Regarding the analysis and interpretation, an insight is that the complexity of adaptive systems and their stochastic behavior often calls for statistical analysis methods. Finally, regarding presentation and packaging, we found that the use of full-blown replication packages can further help future research. Thank you very much for your attention.